All right, everybody, welcome back to our continuation of Chapter 4. Today we'll be talking about Lewis structures for ionic compounds, and this is text section 4.6. A quick review of the ionic bond model that we've been talking about in Chapter 4. Ionic bonds are formed when one or more electrons are transferred from one atom to another atom or between groups of atoms. So according to our two key concepts of bonding, atoms are going to gain or lose the valence electrons to obtain a full octet when forming ionic bonds. So in the example of sodium and chloride coming together to make an ionic bond, sodium has one valence electron. The most efficient way for sodium to get an electron configuration that is a full octet, that's just like the closest noble gas, is for sodium to lose one electron. So sodium will transfer an electron to chlorine. Chlorine has 7 valence electrons. The closest way for it to look like the closest noble gas to get a full octet is to gain 1 electron. So these two make a great pair. Sodium will transfer its 1 electron to chlorine. Sodium ends up being a cation because it lost an electron. It has a full octet, and its electron configuration is isoelectric with neon. It looks just like neons. In chlorine, once it gains an electron, it forms an anion, which means, again, it has a negative charge. It has a full octet. It has 8 electrons in its outermost shell, and its electron configuration looks just like argon, the closest noble gas. And we also say that it's isoelectric with argon. It has the same electron configuration as argon. So again, key things about ionic bonding: electrons are transferred. When electrons are transferred, one atom or atoms are always losing electrons and so becoming cations. And then another atom or group of atoms is always gaining electrons and becoming anions. And it's the attraction between these opposite charges that forms the ionic bond. And so when ionic compounds are formed, you're going to need something that can donate electrons to become a cation. And metals tend to donate electrons to become cations. So when ionic compounds form, you most often have a metal atom that's going to be donating electrons to become a cation, making a bond with a non-metal atom that's going to be accepting those electrons to become an anion. And then you have a positively charged cation attracted to a negatively charged anion, and they form an ionic bond. So the electrons that the metal donates, that the cation donated, are the same electrons that the non-metal accepts. So if we wanted to draw out Lewis dot symbols to show how this bonding works for sodium chloride, it would look like what you see at the bottom here, where sodium has 1 valence electron, and it donates that valence electron to chlorine. So after sodium donates 1 valence electron, we write it as just the symbol for sodium, and we don't draw any more dots around it because it donated that 1 valence electron. But we put brackets around it and a plus sign to show that that's now the sodium cation. And then chlorine gained 1 electron from sodium. So we put all 8 electrons around it. It gained 1 electron into its outermost shell to make a full octet. And we put brackets around it and a negative sign to show that it now has a charge of -1. And the resulting chemical formula for the compound formed between sodium and chloride is NaCl, because it took 1 sodium atom and 1 chlorine atom to make 1 sodium ion and 1 chloride ion to come together to bond to make the ionic compound sodium chloride. So by combining Lewis dot symbols, we can show how ionic bonds are made and the resulting formulas for ionic compounds. So to do this, you want to start out by drawing the Lewis dot symbols for each element involved in the ionic compound. And remember, with the Lewis dot symbols, each dot represents a valence electron. And then you're going to form ions by transferring electrons so that each atom ends up obtaining a full octet. And we'll use arrows to show electron transfers. And then we draw brackets around the ions and we write the charge outside the bracket in the upper right. And then if needed, we can add in more atoms of one or both of the elements so that full octets are obtained by each element involved in the reaction. By the end of the reaction, we want all of the atoms, all of the elements involved to have full octets. And then we can draw the resulting Lewis structure and the chemical formula that's a result of that Lewis structure. So let's do a couple of examples to illustrate that. We'll do the reaction between calcium and chlorine, and then the reaction between sodium and oxygen. If we jump over to a whiteboard here, if we look at the reaction between calcium and chlorine for our first example, to draw this out using Lewis dot structure, we draw the Lewis dot structure for calcium. Has 2 valence electrons, so it gets 2 dots. We draw the Lewis dot structure for chlorine. Chlorine has 7 valence electrons, so it gets 7 dots. And now we need to transfer electrons so that everything involved ends up with a full octet. So chlorine is a metal. Metals tend to donate electrons. And so calcium is going to be donating electrons to chlorine, the nonmetal, and nonmetals tend to gain electrons. So we're going to take our first electron from calcium and transfer it over to chlorine. So now we end up with chlorine having a full octet, but calcium still has 1 valence electron left. And we need to end this reaction with everything involved having full octets. So calcium needs to be able to get rid of both of its valence electrons, and we need to end up with chlorines that all have full outer shells. So to accomplish that, we're going to add in another atom of chlorine to give ourselves another spot. We can put that final valence electron from calcium. So now we can take the second valence electron and put it here. And now what we ended up with is we have calcium, and we put it in brackets with a 2+. It lost both of its valence electrons, so we don't have to draw any dots there. It doesn't have any valence electrons left that it originally had. And it now has a charge of 2+ because it lost 2 electrons. Bonded with 1 chlorine ion with a charge of 1-, and another chlorine ion also with a charge of 1-. And so if we write that as a chemical formula, the chemical formula becomes CaCl2. Ca because we have 1 calcium atom, and Cl2 because we have 2 calcium atoms. And combined, they make up the ionic compound calcium chloride. So let's do another example showing how we can use Lewis dot symbols to have metals and nonmetals come together, transfer electrons to get full octets, fulfill the octet rule, and then come up with the formula for the resulting ionic compound. So our next example is drawing the Lewis dot symbols and the resulting compound when sodium and oxygen react. So we start out by drawing the dot symbol for sodium. Sodium has 1 valence electron. Oxygen has 6. So now we start transferring electrons. So sodium is a metal. It's going to want to give up its electron. So let's transfer 1 electron here to oxygen. So now sodium has lost its 1 valence electron. So this sodium is happy. It looks like the preceding noble gas in terms of its electron configuration. But oxygen doesn't have a full octet yet. We still have 1 empty spot where it needs another electron to fill its octet. And so to fill that spot up, we're going to bring in an additional sodium. Now we can transfer a second electron right up here. And so the result of this is that we end up with Na plus our first sodium that lost an electron and became a sodium ion. Our second sodium that lost an electron and became a sodium ion. And our oxygen that gained 2 electrons become an oxygen ion. And it has a charge of 2- because it gained 2 electrons. So the resulting chemical formula is Na2 because we took 2 sodiums, O, and we only have 1 oxygen. And again, we don't have to write the 1 here. That's just implied. So we leave that blank and we just assume there's a 1. So the resulting chemical formula is Na2O. for the ionic compound that forms between sodium and oxygen. So let's see if we can do a few more. So try these ones on your own first. Pause the video if you need to while you work them out, and then I'll work through them. So draw the Lewis symbols to show the reaction between potassium and chlorine, show the resulting Lewis structure for the ionic compound, and write the formula as well. And then for number 2, draw the Lewis symbols to show the reaction between beryllium and fluorine, and show the resulting Lewis structure and formula for the ionic compound. You can just add in formula. Okay, so for the first one, to try on your own, the Lewis symbols for potassium and chlorine, and show them reacting together, and then write the resulting Lewis structure as well as the formula for the resulting ionic compound. So if we start out with potassium, has 1 valence electron, chlorine has 7 valence electrons. So potassium is a metal. It's going to tend to give up its electrons to make a cation, and chlorine is a nonmetal. It's going to gain electrons to make an anion. So potassium is going to transfer its 1 electron to chlorine. We end up with K plus, the potassium cation, and Cl minus the chlorine anion. And so the resulting chemical formula is therefore KCl. And this is the ionic compound formed between potassium and chlorine. The next example asks you to try out drawing the Lewis dot structures and figuring out the ionic compound and the formula formed between beryllium and fluorine. So beryllium is Be, it's an alkaline earth metal. It's got 2 valence electrons, and fluorine is a halogen. It has 7 valence electrons. So beryllium is a metal. It's going to give up electrons. So let's transfer its first electron over here to fluorine. So now this fluorine is happy. It has a full octet, but we still have 1 electron left on beryllium. And so to get beryllium, so it also has a full octet, to meet the octet rule, we need to bring in another fluorine. So our second beryllium electron will go right there. And now this fluorine also has a full octet, and beryllium donated both of its electrons. So it looks like the electron configuration of the preceding noble gas of helium, which has a full duet. Its outermost shell is completely filled now. So the result is that we end up with Be 2+ ion, because beryllium gave up 2 electrons. And we end up with fluorine 1- and a second fluorine 1- with a full octet as well. So the chemical formula for this would be BeF2. There's 1 beryllium ion, Be2+, and 2 fluorine ions, F1- and a second F1-. So drawing Lewis dot structures is a way that always works to figure out the formulas for ionic compounds. As we get to more complex compounds, I'm going to show you some easier ways to do it, where you can calculate it just based on the number of valence electrons. And we'll go over that in the second half of chapter 4. So next time we'll continue talking about chemical bonding, the ionic bond model, but we'll move on to kind of the second component of chapter 4, which is going to be more of the nomenclature, the naming, and the writing of chemical formulas. And again, you can always use this Lewis dot method. It's going to work, especially if you're a visual person, you like to draw. It's a great way to take these concepts and put them down on paper, moving electrons around. But then we'll go over some other ways also to figure out the formulas of ionic compounds in the next series of lectures. All right, that's it. I hope you all have a good day, and I'll see you next time.